Hey guys, we're gonna keep on rolling right here and we'll move on to 3.4.8. So we're gonna break this up into two parts, and this is the second part of this same page. So as you will see, we actually have the same section number here and the exact same page because we're just gonna kind of like split this one section into two sections here. So you probably realized as you were working that we already talked about multiplying monomials. Remember working with that. Today we're gonna work with the other part of that, which is dividing monomials. All right, and hopefully this is a pretty similar concept for you. So it shouldn't take a lot more for you to kind of understand this. Please make sure that you put this in your notes as well, because this will be the next sort of section that we will be covering. All right. Same deal here. Remember, now we're talking about dividing, so that's this division sign right here. Monomials, remember we said that meant anything with one number, so x, so 7, so 3 to the 8th power, anything that's just kind of a number itself without any addition or subtraction. It might have some multiplication or division, but it is not necessarily addition or subtraction. All right, the question for today that we're going to be asking is this. We will be asking, what happens, hopefully this seems similar to you because we did the same thing yesterday. What happens if we divide numbers with exponents? Right, that's what we're looking at. We're looking at if we have two different numbers that have exponents, what happens if we divide those numbers with exponents? And the same note as last time. Same note, have same base. They have to have the same base. If they don't have the same base, then this is not even something you can do. There's absolutely nothing you can do about it, all right? Remember that when we're talking about a base, if we have like 3 to the 3rd power, this right here is the base. Oh, what a terribly inaccurate arrow. Okay, so remember that they have to have the same base in order for this to be in our realm of possibility, but we are going to be able to divide those monomials. All right, here's a problem that you might get. You might get something that looks like this. Divide. And it will say 3 to the 7th power divided by 3 to the 3rd power. Right, 3 to the 7th power divided by 3 to the 3rd power. And the same deal as yesterday, we need to think about what these numbers actually mean. All right, remember that 3 to the 7th power means 3 times 3 times 3 times 3 times 3 times 3 times 3, or 7 3's all multiplied together. Right? And that what we are doing is we are dividing that by 3 to the 3rd power, or 3 3's multiplied together. Now, we're going to write this a little bit differently because it helps us kind of understand this. You guys know that, like, if I told you to do 1 divided by 3, you could rewrite that as 1 over 3. We can do the same thing here. All right? If we were thinking about 3 to the 7th power divided by 3 to the 3rd, we could rewrite that as 3 to the 7th divided by 3 to the 3rd, right? These are the exact same thing. It's just a different way of arranging it, right? But that way of arranging it is going to be kind of important for us as we try and do the second part of this, all right? Next, we're going to take this, and rather than writing the division right here, I'm going to write it right here, all right? So this is our division. And then I'm going to take our last numbers here and plop them down here on the bottom, all right? 3 to the 3rd power is 3 times 3 times 3. Yeah, these colors are kind of disgusting today. All right, and now hopefully the thing that you realize as you look at this is that we can do some pretty simple mathing that you already know how to do to this problem. All right, just like, for example, if I wrote, let's go 3 times 3 over 3, so this would be 9 over 3. If we had this, is this a finished problem? What do you know that you can do? Well, you know that you can reduce this down. You can reduce this by taking a 3 away from the top and a 3 away from the bottom. So you'd reduce this to a 1 and this to be a 3. Same thing here. We could have, rather than doing the multiplication and then reducing, we could remove a 3 and remove a 3 to give us just 3 over 1. All right? The same thing applies with these problems over here. For every 3 on the top, we can cross it out with the 3 on the bottom because those 3 over 3, a number over itself, is equal to 1. And because of the principle of simplification, right? We're just simplifying these. So what we can do is we can say, all right, I have a 3 up top. I can cross that out with a 3 on the bottom. I have another 3 on the bottom. Let's cross it out with a 3 on top. And then another 3 on the top crosses out with a 3 on the bottom. Now, what we are left with is 3 3s on the top. Or 4 3s, I'm sorry. There are 4 3s still left on the top. Those come from right here. And then on the bottom, we don't have any 3s left. So we just put a 1. And what our final answer is going to be, just like before, 3 times 3 times 3 times 3, or 3 times itself 4 times. 3 to the 4th power would be our final answer. And just like yesterday, let's look at this. So we had 3 to the 7th divided by 3 to the 3rd. And eventually we got to 3 to the 4th. Hopefully you can look at those and kind of see that pattern, picture how those numbers kind of relate to each other. When you look at these and you see how these relate to each other, you can see that once again, just like before, we can rewrite that as 3 to the 7th power, or our first monomial, and then subtract this time the other exponent to give us our final answer, which was 3 to the 4th power. 7 minus 3 is 4. 3 to the 4th power, 3 to the 4th power, same answer. So just like before, there's an easy, simpler way to kind of explain this complicated process of writing it out and crossing off. All right, and here's the essential rule here. All right, write this rule down because this is the very, very important rule. To divide monomials, if I can get my pen to work, to divide monomials with exponents. Oh, sorry. Let's go to divide monomials with the same base. With the same base. Just subtract the exponents. All right, hopefully that seems really similar to what you did yesterday. It's just this time we're doing dividing and subtraction. And those should kind of make sense to you. They kind of go hand in hand. Multiply, add, both are increasing things. Subtract, divide, both are generally decreasing things. All right, so that should be a pretty easy process to remember. All right, this is your important part. Make sure you get this down. To divide monomials with the same base, just subtract the exponents. All right. And so, for simplicity's sake, let's say that, in example 1, I tell you you have 6 to the 3rd power divided by 6 to the 2nd power. Right? And rather than writing out the 6's and doing all the crossing out, we're just going to do it this way. We're just going to write 6 to the 3 minus 2. All right? We just subtracted our exponents, the 3 minus the 2. And 6 to the 3 minus 2 is going to leave us with 6 to the 1st power, or realistically 6 to the 1st power, like we talked about yesterday, is just 6, right? 6 times itself, not at all, or once, I guess would be the one to say it, just 6, right? We have nothing else besides just the 6. All right, let's try the next one. That one's zooming me out. Let's pan it down. Example 2. EX doser. All right, let's say that you were given 4 to the 7th power over 4. Now, this is the same problem, not any different, it's just written in a different way. All right, it's written with the division on the bottom. Remember that this could be interchanged with 4 to the 7th power divided by 4. All right, now this is the same thing that we kind of ran into yesterday. We have to remember what 4 means. 4, if we write it in terms of exponents, is 4 to the 1st power, right? A number is just itself to the 1st power. So what we're going to do is, just like before, we'll do 4 to the 7th. Then we need to subtract our 1. Right, and 7 minus 1 is going to give us 6. Our final answer would be 4 to the 6th power. This applies with variables too. So for example, if you were doing, let's go with y to the 2nd power divided by y to the 1st power, you're going to come up with just y. because it'd be y to the first power. Y to the 2 minus 1 is just going to give you 1, so it will just be y as we get our final answer. So it doesn't make if you have a variable or a number or anything. It's just a matter of subtraction. All right. Hopefully that gives you a little bit of guidance as you're working through these. Let me know if you have any questions. Bye, guys.